Hello everyone. In this video we're going to be solving a functional equation. We have x squared times f of x plus f of 1 minus x is equal to 2x, and we're supposed to find f of x. So in this equation, notice that we have the f twice but with different arguments. So this is what I'd like to do. I'd like to replace x with 1 minus x, and that gives me 1 minus x from here. 1 minus x quantity squared multiplied by f of 1 minus x plus f of 1 minus. Now notice that if I do it here, I get 1 minus x, which is equal to x. So this gives me f of x. And on the right hand side, I get 2 times 1 minus x, which is 2 minus 2x. Great. Now I'm going to write the second equation underneath here, and then I will use elimination. Okay? Let's see how this goes. And by the way, I did not mention which x values are allowable. I didn't want to exclude anything now because I don't want to spoil the surprise, because at the end, there's a surprise. Okay? Let's go. So when I'm done with f of x, I'll tell you which x values should not be in the domain. Great. So what I can do is I can just copy this first one, the original equation here, x squared times f of x plus f of 1 minus x equals 2x. Now my goal is to find f of x, so why don't we just eliminate what we don't want? In this case, it will be f of 1 minus x. So I'll multiply both sides of the second equation by the opposite of this expression right here, which is the negative of 1 minus x quantity squared. And that should give me a nicer equation. So let's go ahead and multiply both sides by that and see what we get from here. We get 1 minus x quantity squared times f of 1 minus x plus f of x. I'm just copying the first one. And the second equation is going to give me negative 1 minus x quantity squared times x squared times f of x minus the quantity 1 minus x squared times f of 1 minus x. And that equals 2x. Of course, that's multiplied by that, so it's going to be negative 2x times 1 minus x quantity squared. Alrighty? So now when we add these two equations side by side, certain things cancel out. And of course, my goal is to find f of x, so it's better if this cancels out, which is f of 1 minus x. And from here, I can just go ahead and add these two expressions and take out the f of x, and then add these two expressions here and get my expression in the simplest form. Okay? So let's go ahead and do that on the next page. So I'm getting f of x minus x squared times 1 minus x quantity squared times f of x equals, and from here I should be getting something like 2 minus 2x minus 2x times the quantity 1 minus x quantity squared, which is going to look like this. 2 minus 2x minus 2x times the quantity 1 minus x squared. So here we can just take out f of x, and if you do, we get 1 minus x squared times the quantity 1 minus x squared divided by, well, we're going to divide it by that at the end. And one of the things I can do here is I can basically factor out a 2 here. And if I do, actually not just a 2, but 2 times quantity 1 minus x, because that's a common factor. And then I should be getting 1 minus, since I take out the 2 and one of the 1 minus x's, I get x times 1 minus x from here. Now I'm going to go ahead and factor this expression, but let me go ahead and do that in the next step. So this expression is kind of factored form, 2 times the quantity 1 minus x. And this we can write as 1 minus x plus x squared divided by, now this is a difference of 2 squares. Notice that? So I can write it as 1 minus x times 1 minus x multiplied by 1 plus x times 1 minus x. Let me explain what I did here real quick, because I was kind of fast maybe. So I took this expression, because it's a difference of 2 squared, I factored it using a squared minus b squared. Of course, I'm dividing both sides by that to get f of x by itself, so it just factored as difference of 2 squares right here. Okay? Now notice that I'm getting what I have in the numerator, this expression here as well, because this is 1 minus x plus x squared. That's also 1 minus x plus x squared. So I can just go ahead and cancel those out. But what if they're equal to 0, right? That should bring some problems. But fortunately, not unfortunately, that expression can never equal 0. Why? Because x squared minus x plus 1 is a quadratic with a negative delta, which is discriminant, so it's never going to be 0. Which means I can safely cancel out the terms. And I end up with something much simpler. Let's go ahead and write that down. So from here, f of x is going to equal, and if I go ahead and distribute this, I should be getting something like 2 minus 2x from the numerator. And the denominator is going to be 1 plus x minus x squared. So that's going to be my expression basically. I mean, if you wanted to simplify this a little bit, like a tiny bit, if you're really picky about writing it in standard form, you can just go ahead and write it this way. 2x minus 2, by negating the top and the bottom, you should be getting something a little nicer, x squared minus x minus 1. And you probably want to do this because we want to look at the expression in the denominator. Well, now why do we want to look at that? Because that's a quadratic, which can be 0. So what we need to do now is basically take this expression and find out which x values are going to make the denominator 0, because we have to exclude those, right? And if you go ahead and find those values, you're going to find something interesting here. So this problem has a golden flavor to it as well. Why? You're going to see in a little bit. If you go ahead and solve this equation, x squared minus x minus 1 equals 0, because you don't want that to be 0, but we want to know which x values we are going to exclude. So from here, you basically get that x should not equal 1 minus root 5 over 2, or x should not equal 1 plus root 5 over 2. And what should that remind you? The golden ratio, right? Hopefully that does make sense. And this brings us to the end of this video. I hope you enjoyed it. Thank you for watching. Please let me know what you think. Don't forget to comment, like, and subscribe. I'll see you tomorrow with another video, which is going to be an awesome problem. So see you tomorrow. Until then, be safe, take care, and bye-bye.